recording.
So-
Hi.
We're going to find out how close a point on this graph, that graph there, comes to the point 0, 2. I'm going to use the distance formula.
Piece of cake.
Which is, do I need to do this? X2 minus x1 squared plus y1 minus y2 squared.
No, why two?
Y2 minus y1 squared, thank you, equals the distance. So this point right here on this curve is x 6 minus x squared. And that point, of course, is 0, 2. So if I say x minus 0, that's just x squared. And for the other point, I can say 6 minus x squared minus 2 squared equals the distance. And then we're going to clean that up. And then we can either take the derivative right now, or we can expand it. How did you guys do it?
I expanded it.
Everybody
Well, I
expand it?
didn't really do it that way. I still do the square root of.
Oh, you got the square root? Okay.
I do it a different way.
So that's going to be what? 16 minus 8x squared
Plus x to the
plus x to the 4th. And that gives me x to the 4th minus 6x. I did something different. Minus 7x squared. Plus 16 equals d squared. This should be squared.
Yeah, actually that'd be.
And then I'm going to take the derivative. And because I've got this in terms of d, I've got to do dd, right. Or dd dx or your y dx or something like that. And I want to minimize this, right? I want to minimize this distance. So, right? So that's okay? You get that derivative or something like that? So that gives you another point. And then we're setting this equal to 0 because I want to know when, if that derivative is equal to 0, this whole side is 0. I'm going to factor out a 2x. I save. And then, so when's that equal to 0? At 0, when x equals 0.
Plus or minus 7.
And,
Excuse me.
right, plus or minus the square root of 7 over 2.
Yeah.
So we got two, we didn't do this yesterday. One of these is probably a maximum, right? Because these are two critical values.
Oh, yeah. 0.
So 0 is probably the maximum. We ought to test this and see. Actually, negative square root of 7 over 2, positive square root of 7 over 2. And this is a derivative, right? This is the derivative, or d prime, or how do I want to write that? D prime.
Sure.
So here's my derivative. Well, actually, I've got the distance will always be positive, right?
Yeah.
So even if I divide both, so if I made this expression here, guys, this is making it more complicated than we need to, but we probably should do it still. d dx. This is always positive, so that won't matter. Up here, so if I pick a number like -1, that's going to be positive, right? Because it'll be a positive over a positive. And if I pick a number like +1, that's negative. And if I go this, well, I don't know. I was just thinking if that's a I wanted to make sure I knew this was the answer. This is what we did yesterday, right? We knew those were the two minimums, but this would be a pause. This would be a maximum.
But don't we already know that's a maximum? Correct.
Except it's coming. It's like this, John, right? Isn't it like? Is this point? As that point goes down, that distance is getting bigger and bigger and bigger.
Yeah, but 0
That's the minimum.
Yeah, but 0 has to be
because
the
x the x value is 0 on the problem.
And that would be a maximum distance.
And
Let's
equals
just.
But it's not, it's a local max, right?
It's not an absolute.
Yeah, it's not.
Right. And then that would be, so as I approach this, it's decreasing, 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 then it would have to be increasing, 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 increasing. So probably on my number line,
Now we're just getting.
right, that would be negative, and that would be positive. So there are the two minimums. Whew, that was a lot more complicated.
Yeah. Just disregard everything.
Okay. So did you guys get that? That was just like the one yesterday. So you get 3 points, and I didn't get it wrong, so I don't have to owe a point to you. Now this one, what's different about this one? Well, what did they give us? They give us a height, yeah, so they give us, so we can draw a picture, right? We know height's 10, the radius is 30, and we know that the water's being the cup's being filled with water, so the water level rises at a rate of 4 centimeters per second. So that's dH dt, right? And what rate is the water being poured into the cup? So what is that? Yeah, we want to find the volume change, right? So we're looking for dV dt. Okay? Remember, that's the first two things. What rate do they give you? What rate do you want to find? So we know the volume of a cone is 1/3 pi r squared h. And we want to get rid of one of these variables. And since we know dH dt, we probably want to get rid of the r. So if we go back to this, setup, these are similar triangles like yesterday, right? So that's filling. We get the radius, the height, so we can know the height is to the radius as the full height is to the full radius. What? Right. So if I do that, I want to get rid of that r. So this is h over r equals 1 over 3. So if we do the cross products, 3h equals r. So then I can go back to this formula, do 1/3 times pi times 3h squared times h. It's not what?
It's 3h.
Actually, it should be 9h squared.
Oh, okay. Yeah. Well,
Yeah. 9h squared. Okay, right? Am I right?
The square is outside.
Well, no, he already squared.
They already squared it, Meg. Want me to do that here?
No.
I can do this.
No, it's fine.
Don't you love that's all getting recorded. 3h squared. So that's 1/3 pi times 9h squared times h. So 1/3 times 9 is 3. So now I'm set to take a derivative. Right, squared. Good, you guys are learning to question me. So dV dt equals 9 pi times h squared times dH dt. Then they're telling me that h is 9. A lot of 9s. And they're telling me that dH dt is 4. So when I did this on a calculator, I went 9 times 81 times 4, and I got 2916 pi cubic centimeters.
Oh, yeah, that's
Second. So the last 2 problems on that big packet from yesterday are the same kind of problems. That's what we're going to do right now. I'm not going to record that.